Part 2 it is. So the first one I want to graph actually isn't one, it's one we already know. I will show you a new way of finding its graph if for some reason it's left you. Suppose in the middle of your deathbed you forgot how to graph y equals tangent of x. So you do remember the trig ID, the tangent is sine over cosine. With your eyeballs still open, we'll look into the denominator and see, there's a cosine curve on the bottom of the tangent expression. So that means I can't divide by 0, so cosine must never be 0. Because it's in the denominator, it can never be 0. So I'm going to draw this because I'm drawing the cosine, because cosine cannot be 0. So I'm going to draw the cosine and see where it is 0. We should be good at drawing them, cosine curves. I think we really would be able to do those on our deathbed. Alright, so here's the old cosine curve. And look where its value is 0. That means where it crosses the x-axis. Right here it's 0, and right here it's 0. So I'm going to dot this function in. So this is not the one. I'm trying to graph tangent. So this is sort of my helper function. So my eyeballs looked over at the expression for tangent. That's what I'm trying to graph here. I know you already know it, but I'm showing you another way, setting up success for these three. So you look at the cosine, you say cosine cannot be 0, so I draw it where cosine is 0. I have to disallow that by an asymptote. So right here, the asymptote appears. Let's go on the other side as well. Over here, if the cosine curve was to continue, it would be a negative pi over 2 would be another 0. Marked in blue. I know it shows up. Alright, so now we put in the asymptote here. So we have these asymptotes. And then we figured it out through a chart, but I'll just remember that it snakes this way, and that's the tangent curve. So knowing that the cosine cannot be 0 helps you remember, even on your deathbed, where the asymptotes are. It's where the cosine curve crosses the x-axis and therefore zeroes out. All right, so now I'm going to do cotangent next. So y equals cotangent x. So my eyeballs are going to look at what the cotangent is, and guess what? Sine is in the denominator. So sine cannot be 0, so I'm going to draw a sine curve, and I'm going to find out that it zeroes out at 2 pi and pi. And it was okay on these other values. So, and I'll take it over on this side. This would give me negative pi over 2. So, when I'm drawing the cotangent curve, I always bring the sine curve around to help me. So I'm going to dot it because it's not the real curve, it's just the helper curve. So that's not the real one. So I'm going to use the helper to find out where the asymptotes are. So there's one, and there's one. So, and here's one over here. Everywhere the sine curve crosses the x-axis is an asymptote for the cotangent curve because sine cannot be 0. And that's what cotangent is equal to, cosine over sine. So it turned out to be a backward snake. So it has different asymptotes than cosine, than tangent. So, and it snakes backwards. This is negative pi. I don't know why I said pi over 2 there. You were copying after me. This asymptote over here is negative pi. And I'll put in 3. And that is the graph of the cotangent curve. Very much like the tangent curve, except the asymptotes are in a different spot and the curve snakes backwards. Alright, so let's see if I can teach the next one. So let's get rid of the eyeballs. We're not going to get rid of them, but we're going to use them in a different way. So now we're doing cosecant y equals cosecant x. And I know cosecant is 1 over sine. It was one of the reciprocal identities we just covered. So my eyeballs are going to look into the denominator and see a sine again. So it's going to have the helper, the sine curve. I'll dot it the first time. Just like this one had the helper. So I'm going to put in asymptotes for this cosecant curve at the same places. 0, negative pi, 0, pi, and 2 pi. Alright, so again, these are going to be asymptotes. Alright, so the difference between cosecant, cotangent, and tangent are vast though. It turns out that the cosecant curve actually looks like a set of u's and upside down u's. They still will fit inside the asymptotes. And I'm going to also note that the sine went up to 1 and down to negative 1 because the cosecant will feed off of that. So what happens is the u I was referring to will fill up the whole area between the asymptote and reflect up the mountain of the sine curve. So, sort of like a reflection. So there's one segment. So when I go over to this segment, I see sine curve went down. The u reflects the valley. And over here, there was another valley. And so the u goes here. So if I was going to keep going on this side, there would be another u over here and another one over here. And you can go on forever in that way. That is a very interesting curve called the cosecant. So one more left for tonight, and that's the secant curve. So the eyeballs are going to help us, and see if you can work ahead of me. If I'm doing y equals secant x, I'm going to realize the secant is 1 over cosine x. So where will the eyeballs go for this one? The eyeballs will look at the denominator, knowing that secant is the same as 1 over cosine. Cosine could never be 0, or we would have a mathematical impossibility. So wherever the cosine will be my helper curve. So I'm going to draw it in. It goes up to 1, down to negative 1. It crosses at pi over 2 and 3 pi over 2. And this one was like the tangent curve in its crossing parts and its asymptotes. So then we have negative pi over 2 and negative 3 pi over 2. Alright, so I'm going to, wherever the cosine curve crosses the x-axis, we're going to have an asymptote. Alright, so just like on this one, it's a set of u's that reflect off of the curve, the helper curve. So we're going to reflect off of the cosine. So wherever it's a mountain, the U looks like that. So you see how this mountain is reflecting. It's like it bends up and reflects like a mirror. And this one, and this one, and this one. And this one would go over here. It would keep going like that. So here we have the secant curve and the cosecant curve. All right, tomorrow you will have to reproduce those. So if you would, practice them in your mind and take an extra look at them after the video is off so that when you come in, you will be able to draw them. All right, that's it for tonight. Have a good one.